Assalamualaikum. Good afternoon, guys. Today we are going to perform experiment Amplitude Shift Keying. For Amplitude Shift Keying, we are going to use the board is modem technology 70074. Let us start the experiment. Let us make the connection. Okay, here you can find ASK, FSK, 2PSK, 4PSK. Okay, so this is the multiplexer, and here this is the modulation part and this is the demodulation part. Okay, so trigger is connected to sync and common, and the board common is connected, and Y1 is connected to the data signal, and Y2 is connected to the output of modulation mux. Okay, the modulator output. So here we have connected this circuit. You can see here this is the common and this is ground. It is grounded with the board, and Y1 is connected to the D and Y2 is connected to the output of mux, which is nothing but output of modulator. Okay, this is the circuit. So let us start the experiment. First step is so you can see the procedure here. Use the mod button located in the board to select SQ format, and the modulation button located on the board to select ASK. Okay, so this is the mod button here. So here we press it, and it will let us make it as SQ format, and let us select this and make ASK modulation. Okay, so when I click again, it will come to FSK, then PSK, then 4PSK. Now I need ASK. Okay, so now after just pressing this, let us go to the setting here. Open the oscilloscope here and select external signal. So trigger, let us select external and let us take it as a positive. It's going up. Okay, and select the time per division as 200 microsecond. Okay, activate the continuous operation mode. Then let us see the output here. So this is the data signal. Let us take Y2. So here this is the ASK signal. Here you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 is your number of pulses in the one data bit. This is the modulation format. So 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 samples in one data sample. Okay, like last class I explained you. So how it is multiplied, the continuous carrier signal is multiplied with the data signal. So when it is 0, you will get 0. When it is 1, you will get as whatever the carrier pulse signal is there, you will get it, and the rest of the thing it is 0. Because of it is multiplied with the 0 of the data signal. So this is amplitude modulator waveform. You can draw it. Let us go to the next part. So how many oscillation of the carrier signal are there in the one bit? How much you have? 8. So you can write the comment about this. Then let us go to the spectrum. So same as the figure, the SQ format, and open the FFT here. Open FFT module. Open FFT here and select it as 25 kilohertz. Make it how much? 25 kilohertz. It is 25 kilohertz. Okay, this is the data signal. Y1 is the data signal. Yes, Y1 is the data signal. So here you can see this pulse, it is 0 hertz. Okay, same like pulse amplitude modulation. So it will be at 0.6, and it is 1.8, 5, 0.0. First pulse is 0, and first Also after 0 is 0.6 kilohertz. You can write here, you can draw here data spectrum, and you can write the frequency at 0.6 kilohertz of the frequency of the data signal. Okay, so simultaneously you can take 1.8 and 3.1 enough. Okay, you can draw just 3, and this is the y1, and let us take y2. It is modulated ASK waveform. The modulated ASK waveform is in the center. You can find here it is 9.95 kilohertz. Okay, and here it will be 9.35 and 10.6. Okay, you can draw just 3 of this. This is the modulated waveform spectrum. Modulated spectrum. Okay, so ASK spectrum, you can draw the data spectrum here, and you can draw the ASK spectrum here. And what the frequency of the data signal is 0.6 kilohertz. So let us go to the demodulation side, see the circuit here. So let me close this and go to the demodulation part. So this is what you will get it. Okay, you got the output like this. Go to the demodulation part. F0 plus FD, F0 minus FD, F0 plus 3FD, F0 minus 3FD. Okay, this is the data spectrum, and this is the carrier signal. So this is the demodulation. Let us make the connection. It is like the same circuit, but data signal we have connected here. The output from the Y1 is connected to the ASK baseband signal, you can see, and this is the output of this. Okay, this is the circuit. These two connection, only these two connection. Okay, rest of the thing is constant. Let us now connect one more thing here. So this is one remaining connection from this point to this point. Okay, so this is what the circuit looks like now. So now, how much was our data spectrum? Data frequency was 0.6 kilohertz, and our modulated waveform center frequency was 0.95, and F0 plus FD, F0 minus FD. Okay, so now we will get back our original data spectrum with the help of demodulation. So demodulation, make the gain adjustment potentiometer the full left. This is the gain potentiometer. You can see the gain potentiometer. This is the gain potentiometer, full left. Okay, on the left side it is. You can move it in the left side and make the modulation mode button to the NRZ format, and again modulation button to the ASK. It is already ASK. Okay, so you can see the circuit again. These two things. Okay, so let us come back to the procedure. Open the oscilloscope. So here is oscilloscope. This is oscilloscope, and make it how much? External trigger as external, and select the positive edge. This is positive edge. So let us record the waveform. We take Y1 and Y2, we got something like this. We'll make it, we'll increase the time period to see properly. So next thing is open the control panel. Let us just minimize this. Open the control panel here. Activate the continuous operation mode for the oscillator and so first we will click this. Okay. So select the data bit here, and or the format we have selected here. ASK demodulation we have selected. So we will select a format as 55 bits. Okay, we will select it as a 55 bits. Okay, and we'll select display both channels. Then let us see what is our output. This is my output. So let me open again oscilloscope for you again. So you can see this part. Just concentrate on this part. So here in each positive pulse 1, 2, 3, 4, 5, 6, 7, 8 pulses are there. Okay. So just you can take this part. How many number of pulses behind the comparator, the data one in the logic one? How many pulses are there? 8 pulses. So here we complete the demodulation part of the ASK. So you can write the conclusion. So I will show you here. So here it is. Okay, like this. You got something like this. Okay. So in each positive pulse, you are getting how much? 8 pulses. Okay. So you can draw both on the same way. Okay. So now let us start with the FSK.